So this video is going to look at a very mini review of all of the basic things that go along with complex numbers. So remember, a complex number is something that looks like this. It's A plus BI. That's a complex number basic form. So it's the real part, right? So it's a real number plus an imaginary number. So we have that letter I coming into play. So some important things to remember, right, is that I is equal to the square root of -1. That's our most basic thing that we really need to know about complex numbers because that pops up a lot. So we have some different skills. So the first skill that we're going to look at is we're going to just add and subtract some complex numbers. So I'm only going to do one example for each skill that I look at today, right? So when you're adding and subtracting complex numbers, your key term there, right, is you want to combine your like terms. Right, so for example, if we want to look at a problem like this, we're going to add the complex number -11 minus 6i. We're going to subtract the complex number 4 plus 10i. So we use those parentheses to kind of just group that this is one complex number and then this is a second complex number. So the first thing we want to do is we want to distribute that negative sign, just like we would with an algebraic expression if we were combining like terms there. So I'm going to leave the first group alone, and then when I distribute, I'm going to get -4 minus 10i. And then I just want to go through and combine my like terms. So I have -11 and -4. That's going to give me -15. And then I look at -6i and -10i, and that's going to give me -16i, and that would be the final answer to that question. So you're just going to combine like terms. Remember, exponents don't change or anything when you're adding and subtracting. You just kind of put them together. So then the second thing that we can do with complex numbers is multiply them. Right, and so we're going to look at an example of that as well. So the example that we're going to look at here is -4 plus 3i times the complex number -12 plus 6i. So remember here, we are going to FOIL or double distribute. You can use the box method, whatever method that you use to multiply two binomials. I'm going to FOIL or double distribute. So I'm going to multiply my -4 times -12, which would give me +48. And then I'm going to multiply -4 plus 6i. So it's going to give me -24i. And then we're going to distribute the second term. So 3i times -12 is going to give me -36i. I like to line up my like terms while I multiply, it just makes life easier. And then we have 3i times 6i, which is going to give me +18i squared. So I'm going to add down to combine my like terms. So I'm going to get 48 minus, let's see, that's going to give me 60i plus 18i squared. So the thing that we want to look out for, right, is that I squared is equal to -1. So anytime we see a I squared in our solution, we never want to leave that as I squared, right? We want to replace that with the real number definition there, right? And we know that I squared has to equal -1 rather, because the definition of I is that I is the square root of -1. So if you square both sides, you get I squared is equal to -1. So if we do that, we get 48 minus 60i, and then we're going to get 18 times -1, so it's going to turn into -18. And then 48 minus 18 is going to give us 30. So we're going to get 30 minus 60i. And that would be the final answer. So your key thing with multiplying is just to remember to multiply like normal, like two binomials, just like normal, and then replace any I squareds with a -1. So one other thing that we're going to look at here is we are also going to simplify negative radicals. Actually, before we do that, let's do a quick division. All right. So the key with division, right, is there are no i's. So no i's can be left in the denominator. And I'm only going to go through an example of dividing by a monomial. So let's look at, we'll do 20 plus 35i. And we are going to divide that by, we'll do 15i. So the first thing I always want to do when I'm dividing is look for any common factors and take them out. So 20, 35, and 15 are all divisible by 5. So the first thing I'm going to do is reduce my fraction by dividing the numerator and denominator by 5. So I'm going to get 4 plus 7i all over 3i, just because we always want those fractions to be in lowest terms. And then I need to get rid of the I in the denominator. So since I is equal to the square root of -1, and we know I squared is equal to just regular -1, if I can make that I in the denominator into I squared, I can easily replace it. So to do that, I am going to multiply both the numerator and the denominator of my fraction by I, which means I'm going to have to distribute in the numerator, which is why I put those parentheses there. So I'm going to get 4i plus 7i squared all over 3i squared. And then anywhere I see I squared, I'm going to replace this with -1, which means I'm going to end up with 4i minus 7 all over -3. And then typically we write the I as the second part of the complex number, so I'm just going to reverse the numerator. And I can leave my answer just like so. Now, the final part of complex numbers that you might need to know how to do is to simplify radicals. So the last little skill here is simplifying negative radicals, or simplifying negative square roots. So for this example, we're going to simplify the square root of -90. So the first thing I'm going to do is I'm going to split the -1 off. So I'm just going to rewrite it as the square root of -1 times the square root of 90. So we know that the square root of -1 is just I. And then I'm just going to focus on simplifying my square root like I normally would. So remember, I want to break that radicand, the number under the radical, into the product of two numbers, one of which is a perfect square, and I want to use the largest perfect square possible. So 90 is pretty easy to break down. I can rewrite the square root of 90 as the square root of 9 times the square root of 10. Right, 9 times 10 is going to give me back the 90. They're both still under square roots because I have not taken a square root yet. And then if I take my square roots, the square root of 9 is 3. And then the square root of 10 is irrational. It's not a perfect square, so I'm just going to leave that alone. And then I'm just going to put my answers together. So I times 3, I'm going to rewrite as 3i, and then tack on the square root of 10 so you don't lose it.